For today's lesson, our focus standard is Grade 8, Expressions and Equations, Topic A, Standard 1. Know and apply the properties of exponents to generate equivalent expressions. So the topic for this video is exponents, proper notation. Our essential question is, what is proper notation when working with exponents, and what does each part tell us? Please take a moment, pausing the video if you need to set up your header, your question column, and your note column, and resume the video when you're ready to begin. Today I want to dive right in, looking at the form for working with exponents. You may have seen something like this before. So this is proper exponent notation. We see a base number, which is usually a large number, with a raised value, a superscript, of a smaller number here. So as I said, the large number is going to that is represented now with a B is your base number. And the superscript, the smaller number raised above, is what that is currently being represented by an E, is the exponent. So in exponential notation, the exponent tells us how many times to repeatedly multiply the base number. So let's take a look at some examples. Here in this first set, in our first problem, I have 3 to the second power, or 3 squared. Which number is my base number? Which number is my exponent? If you said that 3 is the base number and 2 is the exponent, I would agree with you. So let's write an equivalent expression for 3 squared. Again, the exponent tells us how many times to multiply the base number. So 3 squared, or 3 to the second power, will be 3 times 3. 3 multiplied by itself twice. 3 times 3 equals 9. So we could write it as 3 squared, 3 times 3, or 9. Each of those are equivalent. Go ahead and try with the next two. For problem number 2, we have 4 raised to the 6th power. 4 is our base, and our exponent is 6. So if I was to expand out 4 to the 6th power, what would it look like? Exponents represent repeated multiplication of the base number. So we would multiply 4 out 6 times. What does 4 to the 6th power, or 4 multiplied by itself 6 times, equal? 4,096. So again, all 3 of these expressions are equivalent. Let's try one with a negative. So for number 3, we have negative 5 raised to the 3rd power, also sometimes referred to as negative 5 cubed. So if you haven't tried this one yet, go ahead and try it. You said that negative 5 is our base. I would agree. And that makes 3 our exponent. And so negative 5 to the 3rd power, when expanded out, will be negative 5 times negative 5 times negative 5. What does that equal? Well, we know that negative 5 times negative 5 is a positive 25. Times negative 5 is going to make it negative 125. So please take a moment, pausing the video if you need to make sure that so far your notes are complete, that you have everything written down, and then resume the video when you're ready to move on to our second practice set. Here's our second and final set. This time, I've given you each an expression where we have repeated multiplication. And what I would like you to do is now we're going to identify how would I write this as exponential form? What would be my base number? What would be my exponent? Take this problem again and rewrite it in exponential form and then evaluate it. So let's go ahead and try this first one together. We have 6 being multiplied repeatedly. So since 6 is the repeated number being multiplied, 6 is going to be our base number. What is our exponent going to be? To determine this, we have to figure out how many times is it being multiplied. Once, twice, 3 times, 4, 5 times. So we're going to use an exponent of 5. So here's that problem again. 6 multiplied out by itself 5 times. What would that look like in exponential form? If you said 6 raised to the 5th power and you wrote it like this, I would agree with you. To calculate that out, you can multiply 6 times 6 is 36, multiply that by 6, multiply that by 6, multiply that by 6, and you would end up with 7,776. If you had to use a calculator for that one, that's okay. So did I. Go ahead and try problems number 6 and 7, pausing the video if you need to, and then resume the video when you're ready to check your work with mine. So for -2 multiplied by -2 multiplied by -2 multiplied by -2, I would say that our base number is going to be -2. And looking up here at how many times it's being repeatedly multiplied, I would say our exponent is 4. And here I'm just taking that original problem, -2 multiplied out repeatedly 4 times. What would that look like in exponential form? If you wrote -2 as the base and 4 raised above that as an exponent, I would agree, -2 to the 4th power. You will see this oftentimes, some of you have already seen this on our Khan Academy practice sets, where they put the negative in parentheses. That is a helpful thing to do to make sure that we know that that exponent is applied to a negative value. Otherwise, we would be applying the 4, exponent of 4, to a positive 2, and then using the negative, and that would give us a different expression. So when using negative numbers in exponential form, you need to write the negative number in parentheses so that we know that it is a negative value that we are applying this exponent of 4 to. So what is -2 to the 4th power equal when we multiply it out? Well, -2 times -2 is positive 4. Positive 4 times -2 is -8. And -8 times -2 is positive 16. Let's go ahead and try our final problem. Again, here it's just our expanded problem that we started with. So if you thought that the base number should be 1/3, I would agree, and the exponent is 3, because 1/3 is being multiplied by itself 3 times. Again, up here I've used parentheses to keep that as a fraction, because it's important that we do that when we are going to use an exponent so that we know that the exponent applies to the numerator as well as the denominator. So here's our original problem, 1/3 being multiplied by itself 3 times. In exponential form, it would look like 1/3 in parentheses raised to the 3rd power. And if we take 1/3 to the 3rd power, we should end up with 127. So 1 times 1 times 1 is 1, And 3 times 3 is 9, times 3 is 27. So our final answer is 127. That concludes our video for today on proper exponential notation. Please take a moment to make sure that your notes are fully complete, that you have it all written down, and you have included a summary section. Then come prepared to work more with problems like these in class.